So today I'm doing the modeling skin permeability with two permutation pathways. In this figure we're using hydrophobic solutes, and this is due to the two permutation pathways rather than the four to get this Kp value. And because we are looking at the hydrophobic solutes, that's why we're using only the free volume permeability and the lateral permeability of diffusion. This is due to lower molecular weight molecules tend to go through the lipid bilayers through free volume diffusion, and the higher molecular weight goes through lateral diffusion along the lipid layers. And so this models our Kp value, which is free volume and lateral diffusion over the solute partition coefficient of the octanol water ratio. And this is versus our R squared, which is the different solute radiuses. And here, this is how you can see the table of our different solutes. Some are repeated, but still they have around 83 different numbers. And the log of the solute partition coefficient allowed me to solve for the regular coefficient that I need for the equation. And then here on the far right are the experimental permeabilities that are later put in the scatter plot to compare. So here's the first equation I was talking about with the total permeability. Like I said, in figure 2 we only use the free volume and lateral due to the different size of the different weights of the solutes, and we just ignore to make this ratio, I did K free volume over the permeability of free volume over the permeability of lateral diffusion, because that way we can just ignore the solute partition coefficient and just focus on why these two diffusions have different sized solutes, or what types of diffusion these solutes undergo. And I calculated from that free volume equation, we calculated R squared, and that's how I was able to compare my experimental Kp and our predicted Kp with R2. And in this chart Excel graph, you can see column C was it's kind of cut off, but that was just the solute partition coefficient, but we needed column D with the to the power of 0.7. And then you can just go along and see that Kp and free volume and Kp lateral, those are just their constant values, but then we get a new Kp value because we solved for R2 with this new Kp value against the solute partition coefficients. So that's how due to the different solute partition coefficients, that's how I got my new R2 in column G. And then I found our new Kp, which is in column I, and then just used R2 as my x-axis against Kp, the new Kp, which is experimental, and then, the predicted, and then the experimental is what was in the table. And here's my results. As you can see, series 2 is a pretty good, it looks like the same, it looks like figure 2 in the paper. However, I believe my values are slightly off, so that's why it doesn't look exactly like it. But overall, the gist is that the different solute size changes the type of diffusion, as you can see, decreasing radius size, decreasing or increasing the weight changes the diffusion. So, and the Kp value, it will just decrease with the